The next problem we're going to look at is aggregate production planning problem. Aggregate production planning is covered in the operations management class 3110, and here we're going to look at Excel modeling for aggregate production planning. So aggregate production planning is about determining production levels for each time period so that the demand of each of those time periods is met. So here we have a shoe manufacturing company, and they want to develop a production plan, aggregate production plan for 4 months. And they have the demand estimated, and then they have initial inventory available and how much the workers are paid, how much workers can work, and wages and hiring and firing cost and so on. So let's our objective is to develop a production plan, complete production plan that minimizes the total cost. So let's look at the Excel file. So here is the input data given. Let's review the input data. This is given page 152. Okay, so that's our input data. So we have the initial inventory, initial number of workers, regular, so that's the initial condition, and then how many hours one worker works per month, so 160 hours. Maximum overtime allowed is 20 hours. Now if you have to hire a worker, it's going to cost us $1,600. If you have to fire a worker, that's going to cost us $2,000. Regular wages per worker is $1,500. Now overtime wages is given as rate per hour. So for each hour it's $13. Now labor hours needed to produce one pair of shoes is 4 hours. 4 hours of labor. It's also called standard hours. The raw material cost is $15 for one pair of shoes. The holding cost is $3 per pair per month. Okay, so now we need to develop a production plan. So here we're going to look at how many workers we have to hire and fire, and then how many units we have to produce. Yeah. So we have to set up these models. So from number of workers hired and fired, we'll get the capacity to produce, and then we'll determine the production quantity. So first, let's set this worker plan up. So before we start, let's give a name for all of these input values. Okay. Now we have 4 months, and you can set it up for any number of months once you get the model idea understood. Okay. So we're going to start with how many workers we have initially, then how many workers we're going to hire or how many workers we're going to fire. From that we'll figure out how many workers will be available for us to work in that given month. So we're going to set these two rows as changing cells or decision variables. Okay. So initially for the first month we'll begin with the initial number of workers. Okay. And that's the initial number of workers. Plus if we hire any workers, so that will get added to the number of workers. But on the other hand, if we fire workers, then that many workers will be taken out. So we will end up with these many workers after they hire and fire. And those workers will contribute to the production time. Okay. On month 2, we begin with the number of workers we had in month 1. Now we can copy that. We copy this. Then we have the number of workers completed. Now from that we can figure out how many hours of regular time will be available. So you take the number of workers in each month and you multiply by the regular hours per worker per month. That will give us the total hours available in each month. Now, the overtime hours used will make that into changing cells also. Remember, that should be limited to 20 hours per worker. So you take the number of workers, you multiply by the maximum overtime per worker. So that's a constraint that we have to enforce. So given these limitations, the total hours of production that will be available will be regular hours available plus any overtime that we schedule. Okay. That will give us the total hours of productive labor that will be available to us. So if you copy that, that will give us the total hours of production available. So now we have the production plan. So how many shoes we're going to produce, that's going to be changing cells, and how much capacity we have. So you take the total hours of production, you divide by the hours needed, labor hours needed per shoe. That will give you the production capacity. How many shoes can be produced? This is the total hours available. Divide by the labor hours per shoe will give us the production capacity. Copy that. So that will give you the production capacity. So shoes produced must be less than or equal to that. Now inventory after production will be, for the very first month, it will be the initial inventory of shoes plus how many units of shoes will be produced. Okay. Uninventory or inventory after production, and this is the forecasted demand. This is given. So if we take the inventory available after production and subtract the number of shoes that will be shipped out, that will give us the ending inventory. So the next time period, inventory after production will be the ending inventory from the previous time period plus how many shoes we produce in that month. So this will give us the required values. So now once again, the inventory after production must be at least equal to the forecasted demand. Otherwise you'll end up with not being able to satisfy the forecasted demand. So inventory after production has to be greater than or equal to forecasted demand. Once that is satisfied, the ending inventories will not be negative.